Dear student of class 12, now today I'll start the first video of L'Hospital's theorem. Now actually what is L'Hospital's theorem? It's actually this one is a combination of the limit and the derivative. In case of L'Hospital's theorem, you should not make any function or any given equation undefined. Under what circumstances the given function is undefined? Suppose if you are getting 0 upon 0, this is undefined. Any number divided by 0 is also undefined. In this video, I'll discuss these two properties of L'Hospital's theorem, and you have to avoid these two quantities. Now say, if the given quantity is, let us suppose, the limit x tends to a fx over zx. fx over zx. It's a general form of L'Hospital's theorem. Limit x tends to a fx over zx. When you substitute x equals to a, you will get fa over za. If this is equals to undefined, suppose whenever you will substitute the limit x tends to a over here, if your answer is undefined, that means limit does not exist. To make it exist, what you have to do is you have to differentiate numerator and denominator separately. You cannot use u upon v formula. You have to differentiate numerator separately and denominator separately. Now sir, then you have to write using, I'll write in a short form LHR, using L'Hospital's rule. To use L'Hospital's rule, what you have to do is you have to differentiate the numerator. Derivative of fx is f dash x, and derivative of gx is z dash x. Maybe then again you have to substitute these values over here. If your answer is finite answer, if you get the finite answer, that will be your answer. If you didn't get the finite answer, suppose if it is undefined, again you have to use L'Hospital's theorem, provided z dash x must not be equals to 0. Suppose if it is equals to 0 means f dash x divided by 0. Any number divided by 0 is undefined. This is the rule of L'Hospital's theorem. Next, I'll solve some numericals. A student, I'll solve these two questions. Now, the first question is exercise 7.4, the question number 1, so part 1. Limit x tends to 0, sine 2x over x. And another question is limit x tends to 0, e to the power 3x minus 1 over x. Now first of all, I'll verify. First, I'll substitute these values over here. Now say, if I substitute x tends to 0, means 2 into 0 is 0. What you will get? Sine 0. And the value of sine 0 is 0. Divided by f. If I substitute x tends to 0 here, x is 0. Now we are getting, this is, initially if I substitute the limit, and what we are getting, the value is 0 upon 0, which is undefined. In this case, limit does not exist. To make it exist, I'll use L'Hospital's theorem. Using L'Hospital's rule we can write. Now limit x tends to 0, I'll differentiate the numerator. Sine 2x, derivative sine 2x is cos 2x into 2 derivative x is 1, and the derivative of x is 1. Limit x tends to 0, it is 2 cos 2x divided by 1. No need to write divided by 1. Now then again I'll substitute these values. 2 into 0 is 0, 2, and the value of cos 0 is 1. 2 into 1 is 2. This is finite answer. Similarly, this one, I'll substitute x to the power x in terms, I'll substitute over here the 0. 3 into 0 is 0. E to the power 0. E to the power 0. Anything to the power 0 is 1. 1 minus 1 is 0, and this one is also 0, undefined. Again, in this case also the limit does not exist. To make it exist, I'll use using L'Hospital's rule. Now then, limit x tends to 0, I'll differentiate numerator separately and denominator separately. The derivative of e to the power 3x is e to the power 3x into 3 derivative x is 1 minus derivative 1 is 0 over derivative x is 1. Now we have over here limit x tends to 0, 3 into e to the power 3x. Now again, after the derivative, again I'll substitute the limit 3 into e to the power 3 into 0. That is 3 e to the power 0. 3, anything to the power 0 is 1. It is 3. Answer is 3. Finite answer. Another question. Limit x tends to 0, 1 minus cos x over x squared. With it, that you have to substitute the initial value. If you are getting undefined value over here, then we will use L'Hospital's theorem. X tends to 0. Over here 0. Cos 0 is 1. 1 minus 1 is 0. And this one is 0 square is also 0. This is undefined. Now then I'll use using L'Hospital's rule. Limit x tends to 0, derivative 1, 0, minus derivative cos x is minus sin x over derivative x square is 2x. Then this one will be limit x tends to 0, minus into minus plus sin x over 2x. And now one more important concept that you have to keep in your mind. Suppose in denominator, if some variables are left, then again you will get the undefined answer. Now x is there. Again, if I substitute those values, we'll get the undefined answer. X tends to 0, I'll substitute. Sin 0 is 0. 2 into 0 is 0. Again, this one is undefined. If it is again undefined, to get the finite answer using L'Hospital's rule. So one will be limit x tends to 0, derivative sin x is cos x, and derivative 2x is 2 into 1. Now in this case we have limit x tends to 0, cos x by 2. Now no variables are there in a denominator, and now it's a maximum chances to get the answer. Now I'll substitute x tends to 0 here. Cos 0 by 2. Cos 0 is 1. Answer is 1 by 2. And dear student, this chapter is important for 2 marks. Now another important question. Limit x tends to pi by 4, then 1 minus tan x over cos 2x. Now first of all, I'll substitute these values over here. Now say, if I substitute pi by 4 over here, tan pi by 4 means 45 degree. The value of tan 45 is 1. 1 minus 1, 0. Then I'll substitute pi by 4 over here. 2 into pi by 4 means it is pi by 2. Cos 90 degree. Cos 90 is also 0. This is undefined. Now then, using L'Hospital's rule. Limit x tends to pi by 4, derivative 1, 0, minus derivative tan x is sec square x, and derivative cos 2x is minus sin 2x into 2 derivative x is 1. Limit x tends to pi by 4 minus sec square x over 2 sin 2x. Sec 45 degree is root 2. That's it. The maximum chances that we'll get the answer over here. Oh, sorry, minus get cancelled. Now then I'll substitute the value pi by 4. Sec square pi by 4 over 2 into sine 2 into pi by 4. This is pi by 4 means 45 degrees. Sec 45 is root 2 whole square over 2 pi by 2. 2 into sine 90 is 1. And this one root 2 whole square is 2 over 2 into 1. Answer is 1. Now another question. Limit x tends to 0, x minus sin x cos x over x cube. To differentiate these functions over here, that you have to use u into v formula. To avoid u into v, what I'll do is, now it is, we can convert these things in terms of formula. Multiplying both numerator and denominator by 2, then we'll get 2x minus 2 sine x cos x over 2x cubed. Then this one will be, little bit simplification is needed over in this question. 2 sine theta cos theta is sine 2 theta, so that we can avoid u into v derivative. Now then I'll substitute x tends to 0. 2 into 0, 0. Sine 0 is 0. Then what we will get? Sine 0 is 0. 2 into 0 is 0. 0. 0 cube is 0. 0 into 2 is 0. Undefined. Then using L'Hospital's rule, limit x tends to 0. 2 derivative of x is 1. Minus derivative sine 2x is cos 2x into 2. Derivative of x is 1 only. 2 into derivative of x cube is 3x squared. Now then after simplification we'll get limit x tends to 0, 2 minus 2 cos 2x over 6x squared. Now again I'll substitute the value 0. Now still in denominator x square is there, definitely we'll get undefined over here. 2 into 0, 0. Cos 0 is 1. 1 into 2, 2. 2 minus 2, 0. 0 square is 0. Again, undefined. What we'll do? Using L'Hospital's rule. Now then this one will be limit x tends to 0. Derivative 2, 0 minus 2 into derivative cos 2x is minus sine 2x into 2 derivative of x is 1 over 6 into derivative of x square is 2x. Now the limit will be limit x tends to 0, it is minus into minus, plus 2 to the 4 sine 2x over 12x. 4 3 is a 12. Limit x tends to 0, sine 2x over 3x. Sine 2x over 3x. Now again one variable is there in a denominator, that means again that you have to use L'Hospital's rule. 0 substitute. 2 into 0, 0. Sine 0 is 0. 3 into 0, 0. Undefined. I'm using L'Hospital's rule. Limit x tends to 0. Derivative of sine 2x is cos 2x. Cos 2x into 2 derivative of x is 1. 3 derivative of x is 1. Then limit x tends to 0. 2 cos 2x by 3. Now the variable of the denominator is disappear over here. So it's a maximum chance to get the answer. Now I'll substitute 2 cos 2 into 0 is 0 by 3. Cos 0 is 1. Answer is 2 by 3. Now this is the actual concept of L'Hospital's theorem. Go through this numericals and try some numericals. Again, next video also you'll get the video related to L'Hospital's theorem. Thank you.